Well, welcome to the Rock Notes. What are rocks? Well, rocks are simply a mixture of minerals. Now, here's an interesting quote down here. It's not really a quote, but it's an interesting fact. And I like this fact. It says minerals. Let me grab a pen here. Let me change the colors. Oop. Let me do this. What color do we want to work with today? How about we work with, let's work with this dark green. Let's change the lines. So let's take a look down here. It says minerals are rocks, which makes sense. But here it says, but rocks are not minerals. So what we're saying is that minerals can be rocks, but rocks cannot become minerals, that it can't happen. That's true. And we're going to take a look in a few slides and figure out why that is the case. Now, when we classify rocks, we have to really look at their origin. We have to pay special attention to the origin. Well, what is origin? Well, it's simply, where did the rock come from? And that will help us classify what type of rock it is. For example, when we take a look at igneous rocks, I'm going to move this over here. So when we take a look at igneous rocks are rocks that are formed from melted rock. So when we look down in here, if you have a whole bunch of magma happening down here, if it's actually melting, it's going to form igneous rocks. Now, you could have melted rock really close to the surface, and it would still be igneous rocks, because as long as it's melted, it's going to be considered to be igneous rocks. Now, sedimentary rocks are layered accumulations of sediments or fragments of rocks that have been accumulated into layers. Now, if you notice down here, fragments of rocks, minerals, and or animal or plant material. So if we remember when we talked about minerals, minerals are inorganic. So when we looked at that first quote and said all minerals are rocks, but rocks aren't necessarily considered to be minerals, this is why. Because some rocks have plant materials in them, they have animal material in them, and this would make it organic. So those rocks could not be classified as minerals. And the last origin is rocks that are subjected to a lot of heat. So here I already drew this in. You see right here, this would form igneous rocks because it's molten. But if you have rocks forming really close to it, this would be where your metamorphic rocks are. So it's in contact with heated rock, but it's not actually melted, or it's not actually molten. So it's going to change, but it's not going to completely melt. And that's why it would be considered to be metamorphic. So over the next couple series, we're actually going to take a look at these different types of rocks. We're going to take a look at sedimentary rocks, igneous rocks, and metamorphic rocks. So we're going to take a look at igneous rocks first. Now, being molten at some point in time is important, whether they came to the surface that way or not. And a wide variety of rocks are actually formed by different cooling rates. So you can have two rocks, pretty much the same chemical composition, but if it cools quickly, it might form one type of rock, but if it cools slowly, it might form a different type of rock. And likewise, you can also have different rocks cool exactly the same way, but because they have different chemical compositions, they're going to be different rocks. So, here we go. Now, igneous rocks can be classified in several ways. We already talked about the cooling rate, and this would help determine the crystal size. But we also can take a look at the chemical composition. And one of the ways we can do that is by taking a look at silicon dioxide. So if you guys remember, in our last unit, we looked at formulas or chemical symbols. So what does this Si stand for? Yep, silicon. And what does the O stand for? Oxygen. Everybody remember what this stands for? This means there's two oxygens, not two oxygens and silicon, but just two oxygens. So they call this silicon dioxide. The di prefix means two. So igneous rocks can be classified according to the percentage of a silicon dioxide. They can be basaltic, granitic, or they can be andesitic. So let's take a look at one type of rock. One type of rock is basaltic type rocks. And these rocks, sometimes called mafic rocks, are dense, they're heavy, they're dark colored rocks. And let's look at why. These are the types of minerals they have in them. Things like iron. You know, if you think of iron, you think of heavy metals. And it is. Magnesium is a dark colored mineral, and it's also very dense. And these elements make up the molten material, the dense molten material that it forms basaltic type rocks. And basaltic rocks tend to have lower percentages of silica. This is your silicon dioxide. And typically it's less than 52%. So silicon and oxygen tend to be light. So these minerals, basaltic type rocks, I'm sorry, these rocks tend not to have a lot of the less dense material. They tend to have more of the heavy dense elements in them. So that's basaltic rocks. Oop, I've just got to find the right slide here. So one type of basaltic rock is basalt itself, and it's called basaltic rock because basaltic is a prime example of it. It kind of looks like it's ropey, kind of looks like it's lava, or it's just melted, and it's just cooled off, and it has. And if you notice, there's a pick in here, and we put that in there so that you could, well, I didn't put it in here, but the picture I have, the geologists often put devices like this in here so we can get a size perspective when you're taking a picture of it. So you can see it's dark, it looks heavy, and basalt typically is very, very heavy. Now, granitic is the opposite of basaltic. Now, we called it mafic rock. This one is also called felsic, and I don't know if I explained it in the last slide, but mafic and felsic are mainly the same thing as basaltic and granitic. They're just older terms. Every once in a while when I'm reading a geology magazine or a geology article or a geology book, they talk about felsic and they talk about mafic rocks. It means the same thing as basaltic and granitic. Now, granitic is the opposite of basaltic. Look here, we see that they're light colored. The other ones were dark colored. The other ones were very dense. These are lower density. They tend to be thick and stiff, and here they actually have a lot of silica in it, and they have a lot of oxygen in it. And typically these rocks have higher than 66%. So if you remember, basaltic rocks were less than 52. Now these are higher than 66. A good example of a type of granitic rock is granite. Pumice would also be a good example. Rhyolite could be an example of a granitic type rock. Now there's also those in-betweeners. We have the rocks that have, what about those rocks that have greater than 52 but less than 66? Well, they're called andesitic rocks. These have mineral compositions between those of granitic and basaltic rocks. And many volcanoes of the Pacific Ocean are considered to be andesitic rocks. And, you know, basaltic rocks were an example of basaltic, basalt was an example of basaltic rocks, granite's an example of granitic rocks, while andesite is a good example of andesitic rocks. Scoria could be in this category, diorite. Here's another example of diorite. So some of these rocks can actually be considered, could be in both. It really depends on their composition. So don't be surprised if you'll see an example of one rock being andesitic and another example or in another picture they say it's basaltic. It really depends on the percentage of the silica in it. So it could actually be both. Now, igneous rocks can also be classified by the way they cool. We know that intrusive igneous rocks, these cool very slowly. And what I always tell students, how do you remember where intrusive rocks are found? Intrusive rocks are found inside the earth. So I always remember this, intrusive rocks are found inside the earth. And think about this. If you were going to bake something, if you put it inside the oven, and is it going to cool quickly? So when magma cools slowly, usually deep within the earth, the crystals are large and a coarse-grained intrusive igneous rock results. So if you were to put something in the oven, is it going to cool quickly or is it going to cool slowly? Well, it's going to cool very, very slowly because the oven's hot. Especially if you put something in there and then you turn the oven off, it's going to stay warm for hours, potentially. So when igneous rocks, they form inside the earth, that's why they call them intrusive. They're going to cool very, very slowly. And as a result, the crystals are going to get very large. And let's see if we have an example right here. So when we look at diorite, you can see these crystals. You can see them. Typically, you can see them without having to use a microscope or even a magnifying glass. So typically, if you look at an igneous rock and if you can see how large the crystals are, if you can see the crystals, more than likely it's going to be intrusive. Now, the opposite of intrusive are extrusive rocks. And what I always tell the students is, how do you remember extrusive? Well, extrusive rocks have exited the earth. So if you were baking a pizza in that oven again, and if you pull a pizza out of the oven, is it going to cool very quickly or is it going to cool very slowly? Well, if you pull it out now, it's actually going to cool very slowly. So the individual crystals of extrusive rocks, such as basalt, are too small to be seen with the unaided eye because of the rapid, so this is the quick part, they're going to cool very rapidly. And as a result, the crystals are going to be very, very small because it cooled so quickly. So when we look at basalt, it's very hard. You're going to have to get a magnifying glass to see the crystals in that rock. So again, extrusive rocks have cooled very, very quickly. Now, here's another good example of a rock that has cooled very, very quickly. This is obsidian. And what do we know about obsidian? Anybody ever hear of obsidian? Well, obsidian is actually called volcanic glass. And I have a sample I'll pass around. You can actually see light passing through it if it's thin enough. And this actually doesn't have any crystals. For some reason, a piece of magma had the right chemical composition. It was thrust out of say a volcano possibly, and it cooled so quickly that you didn't have any crystals forming at all. Now I call this volcanic glass. Well, take a look at the windows in the back of the room. They're glass too. What is glass made out of? It's made out of sand. What's sand? It's silicon dioxide. So we talked about silicon dioxide being one of the chief minerals in granitic type rocks. Well, you look at the windows, if you heat it up, and that's not necessarily normal sand that you're going to get out of your sandbox, but if you heat up really fine sand, you can actually see straight through it, just like we can see through the windows and back. So we have basaltic, we have granitic, and sometimes we have intermediate rocks or porphyritic rocks. Now, when we take a look at porphyritic and what that means, porphyritic is a term, and it talks about there being coarse crystals in what normally would be a fine grain matrix. So we have some rocks that would be considered porphyritic, and I'll show you an example in just a second. And this happens because sometimes rocks have the characteristics of both intrusive and extrusive. And you might say, well, how can it have both? Did it cool inside the earth or did it cool outside the earth? How can it be both? Well, a rock may actually start to cool very slowly deep within the earth. And for some reason, maybe there was a volcanic eruption, maybe there was some uplifting, but for some reason it actually finished cooling very rapidly deep or rapidly outside the earth or very close to the surface of the earth. And as a result, if we look at this rock right here, it actually started cooling pretty quickly, and in a lot of these areas you don't see any crystals. But for some reason it was thrust up or thrust out of the earth, and then you see these larger crystals. So the larger crystals, the larger crystals actually started forming deep inside the earth, but then it was thrust up, and where you see no crystals at all, that's the part of the rock that cooled outside the earth or very close to the surface of the earth because it cooled very quickly and it's hard to see those crystals without a magnifying glass. So when we take a look at sedimentary rocks next, we'll often refer back to igneous rocks because this is one of the main types, but this does end our talk today on igneous rocks. Hopefully you filled in the notes. If you don't have the fill in a blank notes, you can always go to our website and you can get them. Otherwise, make sure you get some from me in class if you want to fill these out. And these will be very, very important to study for the test. Again, as always, if you have any questions, just ask your science teacher. Thanks. Bye.